Alright, let's talk about the power of xn. So you have to implement the power function, so which calculate x and then raise up to the power of n. So this question is supposed to be easy if you just do it by hand. But if you want to code, this is a little bit of a challenge. So I'm going to just talk about the regular one. So what happens if the base number is 2 and the exponent number? So in this case, I'm going to just say 1. So this is going to be 2, right? And then 2 to 0 is actually equal to 1. And 2 to the negative is 1 over 2, right? So again, this is a pure math. But what is the difficult stuff? This is because you will have to traverse. For the power of n, there are 2 to the 31 minus 1, which is what the boundary of the integer, right? So the total number, this is going to be really large. So this cannot be int. It has to be double. So we need to create a double, but this is not the important stuff. The most important stuff is how do we solve this. So again, let's talk about the solution, like the idea. So we need to make sure what our exponent is positive, right? Before we calculate it, right? So the base number, I'm going to say x. The power is going to be n. I'm going to change another color. This is going to be n. So I don't care the x is positive or negative. This is because this is really easy to calculate it. But I do care about if the n is positive or negative. This is because I have to change my base number to 1 over x, right? And this is what? This is a fraction. And the fraction is what? The double can store it, right? So it doesn't matter like the n is the x is positive or negative, but we have to depending on n, right? N is always what? Integer, right? So again, if the n is what? Is less than 0, we need to flip the x and also change the sign to negative n. So we need to change the sign for negative n. So if the n is already negative, right? Negative 1, just for example. If the n is negative 1, right? We need to make it to what? Negative 1, negative 1, negative 1, which is positive 1, right? So n equals positive 1. So this is how the math down behind. So we need to flip the n, so which flip the x, so which is 1 over x, and n is going to be negative n, right? So we only finished the first step. The second step is what? The second step is calculate the number, the output number, right? It should be what? Should be a really small number or really big number, right? And for the value, how do we solve it? So in this case, we can use a recursion, right? So we already know what? We already know we should store the entire value to double, right? And then we should make this to long, right? So this is pretty much it, right? And then we need to know this could be double, right? So double for x, long for n, and double for output, right? Right. So again, we can use a recursion solution. So let me do this. So we are going to just keep coding the entire the children. So for just for example, 2 to 5. 2 to 5 equal to what? 2 to 2, and then what? Plus what? 3. So this is also equal to 2 to 2 times 2 to 3, right? So we can get 2 to 5, right? So and then 2 to 2 will become what? 2 times 2, right? And 2 to 3 equal to what? 2 times 2 times 2. And then at the end, you just what? Do the math, right? And then this is going to be 2 to 5. So these are the same thing. But we need to just minimize the big problem to stop problem, right? And here it is. So if we know our n, the exponent is actually equal to 0, right? We know this is what? The entire value. It doesn't matter the x. this is going to be what? 1. So you just return 1, right? And then if I know 2 to the 6, right? This is going to be 2 to the 3 times 2 to the 3, right? So we don't actually need to calculate all the way from 2 to the 4 to 2 to the 6. Like, this is not really relevant. This is because when we know 2 to the 3, then we just know 2 to the 3 times 2 to the 3. And this is equal to 2 to the 6, right? So we just have to know what is the half of the value for 2 to the 6, right? So we will say if for the half, right? For the half. So I'm going to just say half. Half is going to be what? Keep calling the helper function. So later on we'll say fast power. And then the base case, the base number is not going to change, but the exponent change to n over 2, right? And then I will have to make sure my n. So I will just check. So check n mod 2 is actually equal to 0, which is even number. Then I can say return half times half, right? If this is even number, 6 is even number, it's going to be 2 to the 3 times 2 to the 3, right? Which is what? Half times half. So what if this is 2 to the 7? 2 to the 7 is going to be exactly the same thing. So this is going to be half, right? This is going to be half 2 to the 3 times 2 to the 3 times 2, right? So we just have to time the base number, which is x, right? So this is going to check n mod 2 equal to 0. Then you return this, and then everything else return half times half times x, right? Which is base number. So for the 7 divided by 2, what? Which is 3, right? So we already know this is half, and then we just have to say times another base number. So 3 plus 3 plus 1. This is 7, right? So this is matched. Alright, too much talking, so let's start coding. So I will have to make sure I store the value for the little n to big N. And if the n is less than 0, right? Then we need to flip our x. And then we need to change our exponent sign to negative n. Alright, then basically we can just say fast power to x and then put the n into it, right? So again, we need a double, right? This is a double function, so we need a double for fast power, double fast power, and then this is going to be double x, and this is going to be long n, right? So again, the base case, if the n equal to 0, I can say the little n right here, right? If the n equal to 0, then I can say return 1, right? And this is double, made a typo. Right, so I need to make sure I have to find half equal to what? Fast power times x, the base number is not going to change, the exponent change to n over 2, right? And then I need to make sure my n exponent mod 2 equal to 0, so I will say return half times half, right? And then if not, this is even, this is not even, which is odd, then I will return half times x, right? And then you will just recursively call it back, and then you return the function. Return a number for the output. So let me just start run it and then see if I have any question. Hopefully no. It looked like I do have a problem. So alright, so just want to make sure this is 1.0 instead of 1. I mean, it doesn't matter, but whatever, right? So let's just do it step by step. So again, if I have 2, and then for the x, 10 for the n, right? 10 for the n, then I will have to make sure, does my 10 is less than 0. No, then I don't have to oncoming. So I still passing 2 and 10, right? So I passing 2 and 10 right over here. So this is better just distinct the color. Alright, so for right now, 2 and 10, n does not equal to 0, so I'm not coming here, right? I'm not coming here. This is what? First iteration, right? So first, I'm going to say first, and n is not equal to n does not equal to 0, right? So I'm not coming to this one, and then I would say half, right? Double half equal to what? 2 does not change, right? 2 does not change, and the exponent change. Exponent change to what? 10 divided by 2, which is 5, right? Then I will go back to the function, right? Now this is what? This is second. This is second iteration. I mean the recursion, right? Second. So now I need to change this to 5. Alright. Does n equal to 0? No. I'm not passing it. So again, half, double half equal to fast power 2. 5 divided by 2, which is 2, right? And calling the function, right? So now this is what? Third. And then now I need to change my exponent to 2. So again, 2. Does my n equal to 0? No, right? So I'm not coming to here. And then let me just write down my number so I don't forget. So now I need to know what is n divided by 2 again. So this is 1, so I call function. So this is going to be 1, right? And this is going to be what? 4 iteration, 4, right? And then I'm going to passing 1. And does 1 equal to 0? No, right? So I would call in this function. Base case not changing. 2 divided by 1 divided by 2, 0, 0. So passing 0. So the last one is going to be 0. And then now does the n is actually equal to 0? True, right? So I will return what? I will return 1, right? Now I'm coming back. So 2, and then I will return, right? So I'm coming back, and then I need to just keep checking. Does my n equal to even? Does my n equal to odd, right? So again, when I return, this is 1, and this is output, right? Output for double fast power, double fast power, and then now this is n equal to 1, right? And then n mod 2 is actually equal to 0. No, 1 is actually an odd number, so I would say half times x, right? But I already know what my half is 1, right? 1 times 1 times 2, so this is 2, right? And then coming back. So so now this is 4th, right? And then I will back to what? Back to 3rd, right? And then let me just write down. So it comes from what? 2. It comes from 1, right? Now I'm like recursively going back, right? So 3. So now this is 2, right? Does my n mod 2 equal to 0? Yes. So what? 2 times 2, right? So this is 4, right? And then do the previous one, which is 5. Does n mod 2 equal to 0? No. So it's going to be what? Half times x. So what is my half? 4. 4 times 4. And then this is 16. 16 times 2, right? 32, right? So 2 to the 5th is 32, right? And then definitely the last one is going to be what? 1024, right? So I don't want to just keep doing this, but you know the idea, right? This is actually power of 2, right? And alright, so submit, whatever. and carrier. So let's talk about time and space. For the space, constant, right? You only need to allocate this alone, but this is constant, right? This one is also constant, doesn't matter. Alright, so how about time? So we only need to know the half of the n. So if this is 2 to the 6, we only need to know until 2 to the 3, right? And then this is going to be what? Half of the n, half of the 6, right? So which is n, right? So this is going to be what? Log n for the time. So this is like 3, but we only need to go through half of it, right? But okay, this is not 3, but whatever. So we only need to go to half of it, and then we will be able to know my output is going to be what? Just based on the exponent is even, then we will just half times half. If this is all, half times times the base number. So this is a solution. So a little bit quite hard understanding, but whatever. So this is supposed to be really pure math. But if you want to just do more fancy, so this is the more fancy one. So just one function. And first thing, check the exponent. If n is less than 0, right, the negative, then you need to flip the base number and then make the exponent to positive, right? And then this is pretty much it, right? And so there's a reason why I need to +1. I mean, there's a math behind it. I don't know. So now I need to just make sure what. I just have to make sure if my n is actually what, the even or odd, right? So I will just keep doing this, x times x, right? And this is x times x times x. So this is a little bit different. Alright, so this is a little bit harder to understand, but I don't want to explain, and the solution is still correct. So whatever. So this is more advanced, and I don't suggest you to write this during the interview. This doesn't help. This one is more helpful. Like probably you can just explain. While you're explaining, you get better credit. The interviewer is going to give you a lot of credit if you can explain this. So I'm finished. So I will see you later. Bye.